Jai Hind, ladies and gentlemen. Aviation Safety India extends a very warm welcome to each one of you. We in Aviation Safety India are very pleased to upload a video presentation on PBN operations. PBN operations require high standards of knowledge, awareness, and alertness on the part of the operators, pilots, engineers, and ATC controllers. I'm sure you'll find this video presentation useful. Let's now move on to the presentation. To begin with, we shall have a look at the regulatory documents. First of all, CAR Section 8, Aircraft Operations, Series S Part 4, Issue 1, 4th September 14, PBN Operations. International Civil Aviation Organization, Performance-Based Manual, ICAO Document 9613. Operation Circulars, Performance-Based Navigations, Operation Circular 6-2, Operation Circular 14 of 2014. Operation Circular 3 of 16, Aircraft and Operators Approval for RNP Approach Operation down to LNAV, VNAV, and LPV minima using GNSS augmented. Operation Circular 05 of 18, dated 24th September 18, use of area navigation substitution to fly conventional instrument procedure up to final approach segment of ILS approach. Operation Circular 1 of 22, 19 January 22, Aircraft and Operators Approval for RNP 0.3 operations. No aircraft shall be operated along ATS routes on an instrument approach procedure or in designated airspace where a navigation specification has been prescribed unless the operator has received authorization from the DGCA. The aircraft is equipped with navigation equipment to enable it to operate in accordance with the prescribed navigation specification. The aircraft is equipped with navigation equipment that continuously provides information to the flight crew of adherence to or departure from track with respect to the required degree of accuracy at any point along that track. No person shall operate an aircraft unless it has sufficient navigation equipment that will enable the aircraft to navigate such that in the event of the failure of any piece of navigation equipment at any stage of flight, the remaining equipment will enable the aircraft to continue to a destination or an alternate destination. Now, what is performance-based navigation? Performance-based navigation is area navigation based on performance requirements for aircraft operating along an ATS route on an instrument approach procedure or in designated airspace. PBN concept specifies system performance requirement in terms of accuracy, integrity, availability, continuity, and functionality needed for the proposed operations. The PBN concept represents a shift from sensor-based to performance-based navigation. Performance requirements are identified in navigation specifications, which also identify the choice of navigation sensors and equipment that may be used to meet the performance requirements. PBN is comprised of area navigation, that is RNAV, and required navigation performance, that is RNP, and describes an aircraft's capability to navigate using performance standards. Now we shall have a look at the navigation functional requirements. Area navigation and required navigation performance specifications include the following requirements for navigation functionalities. First one is continuous indication of aircraft position relative to track display to the pilot flying on a navigation display situated in his primary field of view. Display of distance and bearing to the active 2 waypoint. Display of ground speed or time to the active 2 waypoint. Navigation data storage function. Appropriate failure indication of the area navigation or required navigation performance system, including the sensors. Let's now look at the performance-based navigation specifications. Area navigation 1, that is RNAV, is for departures, arrivals, and certain terminal area operations, that is standard instrument departure and standard instrument arrivals, labeled as RNAV. RNAV 2 is for domestic and route Q&T routes. RNP 1, departure, arrival, and terminal procedures with certain required functions such as RF turns. RNP2 is for domestic and route and offshore and oceanic / remote and route. RNP approach is for instrument approach operations. Procedures titled area navigation GPS. RNP4, RNP10 and RNAV10 is for oceanic operations. RNP authorization required approach and RNP arrival departure approach or departure operations with authorization required. Procedures titled RNAV, RNP or departures titled RNP. Advanced RNP, that is ARNP, it is for en route, terminal and certain approach operations. RNP 0.3, helicopter en route, terminal and certain approach operations. Now, the equipment required for PBN operations, we require 2 GNSS sensors, that is GPS, dual flight management systems, FMS, dual air data systems, dual autopilots, and single inertial reference unit. Now, navigation aids. First, ground-based navigation aids. We have VR and DME. Space-based navigation aids. That's basically global navigation satellite system. We have GPS, US, GLONASS, Russia, Galileo, Europe, Beidou, Compass, China, and India has got NAVIC, which is regional positioning system. Then aircraft-based nav aids, are INS/IRS, FMS, and GNSS and other systems. Let's now discuss operating requirements. First of all, the pilots should not enter published procedures or route waypoints via lat-long, place/bearing, or place-bearing distance into the aircraft system manually. Pilots to accurately track procedure and route center lines as depicted by onboard lateral deviation indicator, that is LDI, displays and or flight guidance during all operations unless otherwise authorized to deviate by air traffic control or in the instance of an emergency condition. RAME or other approved integrity monitor must be available during these operations. Now we shall talk about alternate airport considerations. For the purpose of flight planning, an alternate aerodrome must have an available instrument approach procedure that does not require the use of GPS. This restriction includes conducting a conventional approach at the alternate airport, using a substitute means of navigation that is based upon the use of GPS. DME availability. For navigation relying on DME, no time should be checked to verify the condition of critical DMEs, and the pilots should assess their capability to navigate to an alternate destination in case of failure of critical DME while airborne. DME IRU. Area navigation systems using DME/IRU without GPS input may be used as an alternate means of navigation where valid DME/DME position updating is published as available through NOTAM. In order to use a substitute means of navigation on departure procedures, pilots of aircraft with area navigation systems using DME/IRU without GPS input must ensure their aircraft navigation system position is confirmed within 1,000 feet at the start point of takeoff roll. Let's now discuss pre-flight planning. First of all, the operators and pilots intending to conduct RNAV or RNP operation should file the appropriate flight plan suffixes. The onboard navigation data must be current and appropriate for the region of intended operation and must include the navigation waypoints and relevant coded ATS routes for departure, arrival, and alternate airfields. The availability of navigation infrastructure required for the intended routes, including any known area navigation contingencies, must be confirmed for the period of intended operations using all available information. Since GNSS integrity, that is RAME or airspace signals, is required, the availability of these should also be confirmed. For aircraft navigating with the SBS receivers, operators should check appropriate GPS RAM availability in areas where the airspace signal is unavailable. RAM level required for Area Navigation 1 and Area Navigation 2 can be verified either through NOTAMs or through prediction services. Now we shall discuss general operating procedures. First of all, at system initialization, pilots must confirm the navigation database is current and verify that the aircraft position has been entered correctly. Pilots must verify proper entry of their ATC assigned route upon initial clearance and any subsequent change of route. Pilots must ensure the waypoint sequence depicted by their navigation system matches the route depicted on the appropriate charts and their assigned route. Pilots must not fly an RNAV 1 or RNAV 2 SID or star unless it is retrievable by route name from the onboard navigation database and conforms to the charted route. However, the route may subsequently be modified through the insertion or deletion of specific waypoints in response to ATC clearances. The manual entry or creation of new waypoints by manual entry of latitude and longitude is not permitted. Additionally, pilots must not change any area nav, SID or star database waypoint type from a flyby to a flyover or vice versa. Whenever possible, Area Navigation 1 and Area Navigation 2 routes in the en route domain should be extracted from the database in their entirety rather than loading individual waypoints from the database into the flight plan. However, it is permitted to select and insert individual named fixes oblique waypoints from the navigation database provided all fixes along the published route to be flown are inserted. The route may subsequently be modified through the insertion or deletion of specific waypoints in response to ATC clearances. Pilots should assess their capability to navigate potentially to an alternate airport. Pilots should cross-check the cleared flight plan by comparing charts or other applicable resources with the navigation system, textual display, and the aircraft map display. Pilots, if required, the exclusion of specific nav aid should be confirmed by the pilots. Differences of 3 degrees or less may result from the equipment manufacturer's application of magnetic variation and are operationally acceptable. During the flight, where feasible, the pilot should use available data from ground-based nav aid to confirm navigational reasonableness. Pilots of aircraft with a lateral deviation display must ensure that lateral deviation scaling is suitable for the navigation accuracy associated with the route oblique procedure. Example, full scale deflection plus 1 minus 1 nautical mile for RNAV1 plus minus 2 nautical mile for RNAV2 or plus minus 5 nautical mile for equipment on RNAV2 routes. For normal operations, cross-track error oblique deviation. That is the difference between the area navigation system computed path and the aircraft position related to the path, that is flight technical error, should be limited to plus minus half the navigation accuracy associated with the procedure or route, that is 0.5 nautical mile for area navigation 1 and 1 nautical mile for area navigation 2. Brief deviation from the standard, that is overshoots or undershoots, during and immediately after procedure or route turns, up to a maximum of 1 time the navigation accuracy, that is 1 nautical mile for area navigation 1 and 2 nautical miles for area navigation 2 are allowable. Some aircraft do not display or compute a path during turns. Therefore, pilots of these aircraft may not be able to adhere to the plus minus half lateral deviation navigation accuracy during procedure oblique route turns, but they are still expected to satisfy the standards during intercepts, following turns, and on straight segments. If ATC issues a heading assignment taking the aircraft off a route, the pilot should not modify the flight plan in the area navigation system until a clearance is received to rejoin the route or the controller confirms a new route clearance. When the aircraft is not on the published route, the specified accuracy requirement does not apply. We shall now discuss area navigation standard instrument departure specific requirements. Prior to commencing takeoff, the pilot must verify the aircraft's area navigation system is available, operating correctly, and the correct airport and runway data are loaded. Prior to flight, pilots must verify their aircraft navigation system is operating correctly and the correct runway and departure procedure, including any applicable en route transition, are entered and properly depicted. Pilots who are assigned an area navigation departure procedure and subsequently receive a change of runway, procedure or transition must verify the appropriate changes are entered and available for navigation prior to takeoff. A final check of proper runway entry and correct route depiction shortly before takeoff is recommended. Area navigation engagement altitude. The pilot must be able to use area navigation equipment to follow flight guidance for lateral navigation, that is lateral navigation no later than 153 meters, that is 500 feet above the airport elevation. Pilots must use an authorized method, that is lateral deviation indicator, oblique navigation map display, oblique flight director, oblique autopilot, to achieve an appropriate level of performance. DME/DME aircraft. Pilots of aircraft without GPS using DME/DME sensors without IRU input cannot use their area navigation system until the aircraft has entered adequate DME coverage. DME/DME/IRU aircraft. Pilots of aircraft without GPS using DME/DME area navigation systems with an IRU should ensure the aircraft navigation system position is confirmed within 1000 feet of a known position at the starting point of the takeoff roll. This is usually achieved by the use of an automatic or manual runway update function. A navigation map may also be used to confirm aircraft position if the pilot procedures and the display resolution allow for compliance with the 1000 feet tolerance requirement. We shall now discuss area navigation standard instrument arrivals specific requirements. Prior to the arrival phase, the pilot should verify that the correct terminal route has been loaded. The active flight plan should be checked by comparing the charts with the map display if applicable and the multifunction control and display unit. This includes confirmation of the waypoint sequence, reasonableness of track angles and distances, any altitude or speed constants, and where possible, which waypoints are flyby and which are flyover. Pilots must check and confirm suitable map display. Where the contingency procedures require reversion to a conventional arrival route, necessary preparations must be completed before commencing the area navigation route. Route modifications in the terminal area may take the form of radar headings or direct to clearances, and the pilot must be capable of reacting in a timely fashion. This may include the insertion of tactical waypoints loaded from the database, manual entry or modification by the pilot of the loaded route using temporary waypoints or fixes not provided in the database is not permitted. Pilots must verify their aircraft navigation system is operating correctly. The pilots must notify ATC of any loss of the area navigation capability together with the proposed course of action. And if for any reason unable to comply with the requirements of an area navigation route, pilots must advise ATS as soon as possible. The loss of area navigation capability includes any failure or event causing the aircraft to no longer satisfy the area navigation requirements of the route. In the event of communication failure, the pilot should continue with the area navigation route in accordance with established lost communication procedures. We shall now discuss a very important part, that is pilot's knowledge and training requirements. The pilot should be familiar with DCA car circulars and IKO, manual on PBN operations. The pilot should know the meaning and proper use of aircraft equipment, oblique navigation suffixes. Procedure characteristics as determined from chart depiction and textual description. Depiction of waypoint types, whether flyover or flyby, and path terminators, and any other types used by the operator, as well as associated aircraft flight paths. Required navigation equipment for operation on area navigation routes, SIDS oblique stars, example DME oblique DME, DME oblique DME oblique IRU, and global navigation satellite systems. Area navigation system, they should have knowledge about the specific information. Levels of automation, mode annunciations, changes, alerts, interactions, reversions, and degradation. Functional integration with other aircraft systems, the meaning and appropriateness of route discontinuities, as well as related flight crew procedures. Pilot procedures consistent with the operation. Types of navigation sensors, example DME, IRU, GNSS, which are utilized by the area navigation system, and associated system prioritization, oblique weighting, oblique logic. Turn anticipation with consideration to speed and altitude effect. Interpretation of electronic displays and symbols. Understanding of the aircraft configuration and operational conditions required to support area navigation operations. That is appropriate selection of CDI scaling for lateral deviation display scaling. Area navigation equipment operating procedures as applicable, including how to perform the following actions. Verify the currency and integrity of the aircraft navigation data. Pilot should also know how to verify the successful completion of area navigation system self-tests, initialize navigation system position, retrieve and fly a SID or a star with appropriate transition. Adhere to speed and or altitude constants associated with a SID or star. They should be able to select the appropriate star or SID for the active runway in use and should be familiar with procedures to deal with the runway change. Perform a manual or automatic update with takeoff point shift if applicable. Verify waypoints and flight plan programming. Fly direct to a waypoint. Fly a course oblique track to a waypoint. Intercept a course oblique track. Following vectors and rejoining an area navigation route from heading mode. Determine cross-track error oblique deviation. More specifically, the maximum deviation allowed to support area navigation must be understood and respected. Resolve route discontinuities. Remove and reselect navigation sensor input. When required, confirm exclusion of a specific NAVAID or NAVAID type. When required by the State Aviation Authority, perform gross navigation error checks using conventional NAVAID, change arrival airport, and alternate airport. Perform parallel offset function. If capability exists, pilots should know how offsets are applied, the functionality of the particular air navigation system, the need to advise ATC if this functionality is not available, perform runway area navigation holding functions. Operator recommended level of automation for phase of flight and workload, including methods to minimize cross-track error, track error to maintain route center line. Now this PBN endorsement is granted after the pilot has successfully completed a course of theoretical knowledge, including performance-based navigation. The pilot has successfully completed flying training, including PBN. The pilot has successfully completed either a skill test or a proficiency check. Thank you, ladies and gentlemen, for sparing your precious time to watch this video presentation on PBN operations. Operators and pilots are requested to make a summary of DGCA cards and circulars on the conduct of PBN operations. The same can be kept in operators library for easy availability for reference by pilots and engineers. Wishing you all a very safe flying and many happy landings. Jai Hind.